Hello and welcome to R&D Math. Today we are going to talk more about row operations. Now let's take an example. x1 minus 3x2 plus x3 equals 1. See, this is same as x minus 3y plus c equals 1. So you can use these notations. This way of writing variables is really helpful when you have more variables. So 2x1 minus x2 minus 2x3 equals 2, and x1 plus 2x2 minus 3x3 equals -1. Now let's write down our augmented matrix. 1, -3, 1, 2, -1, -2. So you are just writing down those coefficients, 1, 2, -3. And the augment 1, 2, -1. Okay, so the first row operation, I would like to make this place 0. So -2 times R1 plus R2 on R2. If I do that, and I'm not going to change my first row, so let me write that down. So if I do this operation, -2 times 1, -2 and 2, I get 0, -2 into -3 is 6, -1 plus -1, so 5, and -2 into 1, -2 plus -2, so -4, and -2 plus 2, and I'm getting 0. Next one, see, I'm going to do the, see, at this point, if I want, I can write this row like this and do the next operation. But as I told you last time, I can do one more operation, another operation in the same step. So I will do, you don't have to draw another arrow, but I will do -1 times R1 plus R3 on R3, right? So in that case, I get 0 here, and I get 5 here, and I get -1 times, so -4, and -1, and I get -2, right? Now, next I would like to make this place 0. So let's see what's the operation. How about -R2, so -1 times R2 plus R3 on R3. Now let me write it over here. So first row, it does not change. Sorry, first row like this, and then second row, I'm not going to change it. Third row, so I'll add -1 times second row to third row. I'm getting 0 here. -5 and 5 is 0. -4 plus 4 minus 4, 0. And 0, I get -2. Now, this example, this is pretty much it at this point. Now, I want you to look at this last row. This means 0x plus 0y equals 0z plus 0z equals -2. Now, in this case, 0x, 0y, so 0, left hand side is 0, right? 0 into anything is 0, is -2. Now, this is wrong. You end up having something wrong. This means if you had a row like this, 0, 0, 0, and some number, 0, 0, 0, and a non-zero number, that means no solutions. No solutions. Now, let's take a 2 by 2 example, then it's easy to understand in this case. So let's say x plus 3y equals 4 and 2x plus 6y equals 5. Now 1, 3, 2, 6, 4, 5, right? Let's do row operations. In order to get rid of this guy, what I'm going to do, negative 2 times r1 plus r2 on r2. If I do that, let's keep our first row as it is, and then negative 2 into 1, negative 2 plus 2, 0, negative 2 into 3, negative 6 plus 6, 0, negative 2 into 4, negative 8 plus 5, negative 3. See again, I choose an example exactly like before. So 0x plus 0y equals negative 3. That will never happen. That means 0 equals negative 3, and that is wrong. So that means no solutions. Now at this point, using this 2 by 2, it's easy to explain why they have no solutions. Now look at these numbers. Look at this one. From this one, if I solve for y is going to be, okay, 3y is 4 minus x, and when I divide by 3, I get this. Let me take it over here. Y equals negative x over 3 plus 4 over 3. And from the second equation, if I solve for y, 6y is going to be 5 minus 2x over 6y is 5 minus 2x, and y is 5 minus 2x over 6. So y is negative 2x over 6 plus 5 over 6. So I am putting this in y equals mx plus b form because it's easy to draw it in a graph. Now look at these numbers. This one is actually negative 6 over 2. That means this is negative x over 3, because negative 2 and 2 times 3 is 6, plus 5 over 6. Now look at these two equations. This one slope negative 1/3, this one slope negative 1/3, and we have a negative slope and 4 over 3 somewhere here. So we have a line like this, and here the same slope, second one, the same slope, but it's going through another point, 5 over 6. That means somewhere here. Now the point is, because they have the same slope, they are parallel lines. They will never meet. See, they will never meet. That's why no solutions. So remember guys, whenever you end up in your row operations, if you have, it can be 3 by 3, 4 by 4, 2 by 2, and if you have a non-zero number, that means 0 equals that non-zero number, that it will never happen. If that is the case, we have no solutions. Now I'll end in this video here. Last time in our example, what happened was 1 0 0 0 1 0 0 0 1, and you got some numbers, let's say 5 6 and 8. That means x is 5, y is 6, c is 8, and that has exactly one solution. It's a nice system, it's a consistent system, and we'll talk about those names in our next video, because there is one more case. This is one or unique solution, and this case no solution, and there is one more case, and that's going to be our next video. Okay, thank you.